hope this is going to be a short and easy video, especially if you already have read the post that I published some days ago, where I explained how to set up a WireGuard over TCP using udp2raw. Here you have the complete explanation and details with a very basic scenario where you have just one peer, or in the end a peer-to-peer connection. So just two peers in remote endpoints, changing information or setting up a VPN through a TCP connection when you for sure already know that WireGuard in theory only works on UDP. So based on that, I decided to evolve that scenario, and then I posted this new entry in my blog. This is for demonstrating that the same scenario can work in a point-to-multipoint architecture. Okay, exactly the same theory, but in this case with multiple remote points, remote peers. Okay, the host P and the host C are going to connect to the host A using a TCP connection. Here you have the schema in mostly full screen. We are going to have WireGuard as a client of the server that we have in the peer A, but instead of connecting the UDP through the firewall and the other network stuff that we have in the middle, what is going to happen as it will be packed on top of a TCP socket created using udp2raw. udp2raw will connect to another udp2raw in the peer A. The same thing is going to happen in peer C. So it's going to be two TCP sockets connecting to the central host A, and then unpacking those TCP connections on two UDP connections through the WireGuard. Okay, what's going to be possible thanks to that? Then, for instance, when I ping to Google, thanks to this scenario, the traffic will be packed on the tunnel, and then it will be redirected to Google. The same thing could happen if I ping to a service that it is behind that host A in the local network of the host A. Okay, in the post you have a quick cookbook. So no details, no explanations, no verbose, just the quick comments that you can copy and paste, just modifying the minimal things that you need for adapting this scenario to your real scenario. What I did, it is I created a temporary virtual machine in DigitalOcean with this public IP. Of course, this IP will be stopped at the end of this video, and then this is going to be host A. Yeah, so it's going to have the private IP 111.1. Yeah, the one that you have here. Okay. Also, we have that public IP address. The public IP address ended with 97. So if I now going to connect to peer B and peer C, okay, what I can see, let me go here. Here I have host B and here I have host C. Okay, in host B, if I just take a look on the configuration, it is exactly the same configuration file that you have available. This is host A, host B, same one that you have here. Okay, thanks to this, where is it? To this command that I have here, this one. Okay. The tunnel is going to be enabled, or is going to be set up automatically when the machine reboots. Okay, this is going what it happened here. Just with the command WG, I can see the status. Everything seems okay. And then if I ping to the public IP address. Yeah, here it is. If I connect to one of those systems that just give me my public IP address, I can notice that I am navigating through the IP address .97. Yeah. If I stop the tunnel and I request my public IP address, you can notice that it is a completely different one, ended with 64. When I run the tunnel again, yeah, let me check firstly that the tunnel is running. It is, and then notice again I am navigating through the host A. Yeah, I was in host B. Now the same thing happens with host C. Yeah, and the same thing with the public IP address. Yeah, here it is. If I take a look on MTR, for instance, I want to discover the trace that I have when I'm connecting to Google. Here you can see that I am navigating through the IP address of host A. Yeah. If I go to host A, the same thing. I can ping in the IP2 and in the IP3. Everything is working. Something interesting to comment here. If I ping to IP address number 2, so the host B IP address from the host C, it is going to work, but notice that the ping time is exactly the double time because it has to travel through the host 1. Yeah, notice that for pinging .2, I have to firstly go through the tunnel to the IP1 and then jump to the IP2. Yeah, if you want to cut that, what you have to do it is create the proper IP tables for filtering this traffic. Okay, as I said at the very beginning, this is going to be a short video, so I'm not going to take long for describing the scenario. Here you have the post with the cookbook, as I said at the beginning, for implementing this useful scenario. Nothing else. Thank you very much.